Morning, students. Myself, Dr. Pawan C.Tapre, HVDC of Electrical Engineering Department, SND College of Engineering, Yeola. Today, we will discuss on the subject Power System 2, Unit number 6. The topic is the types of HVDC link. It is the lecture number 4. So, types of HVDC links. There are three types of HVDC links. First is monopolar link, second is bipolar link, and third is homopolar link. First, in monopolar link, the circuit shows the monopolar link. It is the source. Here is the converter, which converts the AC into the DC. There is single line is connected, and again the converter is at the receiving end, which converts DC into the AC. So, in monopolar link, having one conductor of negative polarity and ground is used as a return path. Here we use the ground as a return. We can operate either in positive or negative polarity. We can take this the either positive polarity or the negative polarity. Okay, but usually prefer negative polarity in order to reduce the corona effect. For reducing the corona effect, we take the negative polarity and positive as a ground. Okay. So the major drawback in this system is the power flow is interrupted due to the either converter failure or DC. So the power is converter failure or it is the DC link field. If the conductor is breakdown, so then the power is not flowing through the transmission line, or if any converter has any problem or maintenance issue, then time the power is not flow from this link. Okay. The ground return is objectionable only when the buried metallic structures, such as pipe, are present and are subject to corrosion with the DC current flow. So, when the metallic structure is there, so at that time, the ground return is a objectionable part. Okay. Second is the bipolar link. So here bipolar link is present. So here is the source. There is a transformer, whether it is step-up transformer or whether it is step-down transformer. So at the sending end, we use the step-up transformer, but at the receiving end, we use the step-down transformer. Here is a converter which is provided for the every line. For this line, one converter is provided. For this line, one converter is provided. Similarly, at the receiving end, two converter is provided for the one line and second line. Here, this point is grounded. Okay. So in bipolar link, there are two conductors. One conductor is the upper side and second conductor is the lower side. One is operate at positive and another is negative. So if this conductor is positive polarity, then this conductor is the negative polarity. So during the fault, if one pole is, it will operate as a monopolar link. This is very popular in the breakdown at the time of this conductor by using monopolar link. Okay, so this bipolar link is very popular in the HVDC system. So third type of DC link is the homopolar. So in polar, like bipolar, there is a homopolar, but here in conductor or both link we use as a negative converter. Same step down, a step of transform is connected to the AC source and step down is connected to the receiving end, and this converter convert the AC into DC. In this link, two or more conductors have same polarity. Normally, negative polarity are used to less corona loss and radio interference. So we use the negative polarity because we reduce by using this negative polarity, we reduce corona loss and also the radio interference. Here the ground is always used as a return path. So ground we can use as a always return path. So during a fault in one pole, it works as a monopolar. If fault is occurring in any one conductor, then we can use the second conductor as a monopolar. So what is the application of HVDC link? The main area of the application based on the economics and technical performance are first, long distance bulk power transmission means we can transmit the heavy amount of the power from one end to another end. Second, the undergoing of underground of submarine cable. ठीक है. For that purpose, submarine cables के लिए we can use the HVDC transmission line. Third, asynchronous connection of the AC system with different frequencies. We can connect two different systems by different frequency by using HVDC link. Last, control and stabilize the power system with the power flow control. We can control the power flow power and stabilize the power. So based on the there are three types of HVDC possible. First, bulk power transmission. Second, back-to-back connection, and third, modulation of the AC power. So purpose of AC HVDC based on the interconnection, the bulk power transmission. So transfer the power from one end to another end without tapping power in between. So we can transmit the power from one end to another end without tapping. For this, DC system is the best option, or HVDC transmission where the bulk power is transmitted from one point to another point over a long distance. Second is the power flow control, means back-to-back HVDC system. If two regions are very nearby, we can monitor the power flow from one region to another to control emergency support as per our requirement, or back-to-back link where rectification and then inversion is carried out in the same converter station with very small or no DC line. So if the two region is very near, we can control the power. Okay. Next is to provide stability to the AC system. In this, AC basically used to control the power and stabilize the system. It is also used to connect two different frequency systems. Modulation of the AC system is connected parallel with the DC system or parallel connection of the AC and DC. Where both AC and DC run parallel, it is mainly used to modulate the power of AC line. HVDC is the better option for the above cited purpose where compared with the its AC system. Thank you for attending this lecture.